Hi, everybody. So I'm sorry that I couldn't be there with you today. I just wanted to go ahead and make a quick video to go over some of the ideas from our last class period, which are all about residuals. And after this video, you guys are going to be doing some practice today with everything that we've learned so far in this unit. And the very first thing is going to be a review of residuals. So let's go ahead and talk about what we learned last time, which is all about residuals. While I'm going through this video, I would appreciate if you guys could take some notes about this in the back of your packet on one of the blank pages that you'll find there. So again, the big topic of the day is all about residuals. The first thing I want to review is what is a residual and how do we calculate it? So a residual helps us measure the difference between what actually happened in an experiment and what we predicted was going to happen in an experiment. To calculate a residual, we do it by finding the actual value of what happened, and we subtract the predicted value of what happened. Now, I do want to make a couple notes here. To find the actual value of what happened in an experiment, you can do that in a couple different ways. You can look at a table of values that was given and find the designated point, or you can look at the graph that was given and find the designated point on the graph. The important thing here is that we are not looking at the line of best fit or using the equation of the line of best fit to find this number. We're looking at the table or we're looking at the points on the graph. Now, to find the predicted value of what we thought was going to happen, we're going to use the equation of the line of best fit. So you're actually going to take your number and plug it into the equation or use the numbers that were given on a graph for the equation of the line of best fit. And that is how we calculate a residual. Now, after we've calculated a residual, we're going to be asked to do two different things. We're going to be asked to interpret a residual, and we're going to be asked to determine whether our line of best fit was an overestimate or an underestimate. Let me give you an example of interpreting first. When we interpret a residual, every sentence is going to start the same way. When the x variable is some specific number. So for example, if you're finding the residual for what happened when we were 6 pieces of spaghetti, like we did the other day in class, you would say when the number of spaghetti pieces is 2. And then you're going to say the actual value of whatever the y variable was. When we did this example in class the other day, we did an example where the y variable was the number of pennies. So we would say the actual value of the number of pennies is, and then you're going to tell me what the difference is. This much higher or lower. And this is going to be the number of the residual. And this is going to be either higher or lower. The other day when we did this experiment in class, we said that when there were 2 pieces of spaghetti, the actual value was actually 10.77 higher than the predicted value. And that's how we finish our sentence, than the predicted value. Now, one note that I want to make is that you're going to choose the word lower here when the residual is negative. So if you get a negative number for your residual, then you choose the word lower here. And if you get a positive number, you choose the word higher here. And that is how we interpret a residual. The last thing that I might ask you to do when you are done interpreting your residual is I might ask you to tell me, was the best fit line an over prediction or an under prediction? Now I'm going to scroll down a little bit so that you have a little bit more space. The last thing I might ask you to do is to determine whether the line over predicts the data or under predicts the data. Now, in order to do that, you can do this in two different ways. If you have a graph, you're going to say that the line over predicts when the line is above the data point. And if you have a graph, you're going to say that the line under predicts if the line is below the data point. So for example, if I was looking at a graph like this and I said, what's happening with this data point? Because the line is over the data point, it's an over prediction. And if I was looking at a graph like this and the line was below the data point, I would say that because the line is below, it's an under prediction. However, we don't always have a graph. So another way to determine whether you have an over prediction or an under prediction is when you have the equation of the line. When you have when you have a residual instead of having an equation. If your residual is negative, so you calculated your residual or somebody told you the residual is negative 0.22, if the residual is negative, you're going to have an over prediction. And if your residual is positive, you're going to have an under prediction. And that is sort of the example that we saw in class the other day when we were practicing this, is we looked at our residual numbers and we said, is this an over or an under prediction? And we noticed based on the pattern in our table that this is what was going on. Now, in order to make sure we fully understand what's going on today, I do want to take a second and go over one example with you. And this is an example that was in your homework assignment. So if you guys could please look at page 36 in your packet, we are going to go over the example at the bottom of page 36. So at the bottom of page 36, it says, the data point on a scatter plot of 32,6 represents a person who is 32 years old with 6 years of experience in her field of expertise. The regression line for this scatter plot predicts that a 32-year-old person would have 5.73 years of experience. And then it asks us to do three things. Again, this is page 36. And it's towards the bottom of the page. It's sort of the word problem at the bottom. The first thing that the problem asks us to do is to calculate the residual. So for part A, where I'm asked to calculate the residual, I always like to go back to the equation, actual value minus predicted value. Now in this example, it actually tells us the actual value. It says, a data point on the graph showed us that a person who's 32 years old has 6 years of experience. So the actual value here would be 6. minus the predicted value. And again, the problem actually tells us the predicted value here is 5.73 years of field experience. So because those two values are the actual value and the predicted value, now I'm just going to use my calculator and I'm going to type that in. And I get that my residual is 0.27. For part B of this question, it asks me whether this was an over prediction or an under prediction. Because the residual is positive, I know that this is going to be an under prediction. And what we talked about in class last time, a good way to remember that is opposites attract. So a positive residual gives you an under prediction. And I would say because the residual is positive. The last part of the question here asks me to interpret the meaning of the residual. So I'm going to start this sentence by talking about the x value of that ordered pair, which was 32. So I would say when a person is 32 years old. So I'm always going to start with the x. Then I'm always going to start by saying the actual value because the actual value is the first thing in my equation when I calculated my residual. So it's the first thing I'm going to put in my sentence explaining what it means. So I would say the actual value of, and the thing that we measured, the y, is the years of experience. Is, and now I'm going to use this specific number. This specific number says 0.27, so I would say 0.27 higher, and I'm using the word higher because that's a positive number, than the predicted value. And I'm ending with the predicted value just like this equation ended with the predicted value. All right, that was our brief recap of what happened last time. Again, the next thing that you guys are going to do is a little bit of practice, and I will see you on Thursday to go over any questions that you have and make sure we're totally ready with this material and we understand it before we take our test. Have a great day today. I hope you guys all have fun practicing, and I'll see you soon.